Hello, welcome to Supercharged Math. It is summertime. I've had a couple of weeks off. I'm rested, but it's time to get back into some math. We are learning statistics. Yes, statistics. So that is the topic of the unit we're on. We will have 4 weeks of this. I intend to make 4 videos like this one, and I want them to each be about an hour long. I will briefly introduce my beautiful assistant Mocha, who is not going to be any help whatsoever in the statistics unit. She's here to look pretty. Don't touch the tripod. Okay, and just point out that today's shirt is Liverpool. I'm quite happy to be wearing this shirt because I forgot that I had it for, I believe, about 2 years. I have these dresser drawers that have these shirts, and there was a drawer I was just never going into. And then I found this one recently. Hey, I forgot about that green Liverpool shirt. Okay, so let's get into the real topics of this lesson, statistics. We are going to talk about what statistics is. Statistics is the study of data. We collect data and then we ask questions about it and we try to learn things. Not the most graceful definition. What is data? Data is a collection of facts. So, the first thing we're going to talk about is this stuff here, where we talk about the types of data that we encounter when we start studying statistics. We can have categorical data and we can have numerical data. Examples of data. I can ask a lot of people their favorite color. And some of the answers will be red and blue and green and red and red and blue and green. And this is an example of categorical data. Because it's not numbers, it's not numerical. When you have numbers, you can do interesting things with numbers, like finding the average of a bunch of numbers, but you can't really do that with categorical data. You can't find the average of red, 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 blue, blue, green, red. So that's one of the basic concepts that we want to get into when we learn to look at the data that we're collecting or that we're studying and realize whether it's categorical or numerical. And then we treat the data differently. It's still data, it's still useful, even if it is not numerical. Let's look at some examples. I have some examples here. Okay, so we already talked about favorite color. Let me think here. We find out how many pets each of the students in a class has. The data is going to be numbers like 2 pets, or 0 pets, 1 pet, 4 pets. This is numerical. So we're just looking at whether it's numbers or not. And that is the fast way of making a quick decision about whether your data is categorical or numerical. The next idea is, and I'll write it, I'll get it on the chalkboard. We can have statistical data and we can have non-statistical data. Okay, this is going to take a bit of time to write. Non-statistical. I promise that I'm not going to write that word again in the rest of this lesson. Boy, does that ever look crooked. I think it's my camera that's a little bit crooked. I'll see if I can fix it just a bit. See if I like it. I think that's a little better. I think I can see a little bit of the ceiling now. Okay, so we have statistical data and non-statistical. Statistical questions can be answered by using data. And the data has to be able to vary. So let's look at some of the examples we already talked about. The idea of doing a survey where we ask a bunch of students how many pets they have. If you ask me how many pets I have, there's just one answer. I have one. Her name is Mocha. So that is not statistical. That's non-statistical because it's not going to vary. I have one pet. It's not going to change. And why is it not varying? Because we're only asking me. We're only asking one person. We're not asking me a lot of questions. We're just asking me one question. When there's only one answer, like, yes, I only have one pet, it's Mocha, that is an example of non-statistical. How could we make that question become statistical, though? Can we? Yes, simply by asking more people, for instance. If I ask all the people who live on my street how many pets they have, well, now the answers can vary. I have one, the people next door have two, the people next door, I think they don't have any, but I'm not sure. They may have a fish or something. So the answers vary. Some houses will have 5 pets, some houses will have none, some will have 2. Because the answers can vary, we have statistical question. We can look at a lot of data that we can collect, and we can examine whether it's numerical or categorical, statistical or non-statistical. This thing about numerical and categorical, though, I think I'd like to get back into that because I have an example that I find is the exception that proves the rule. It's the example I really like to use. When we have numbers, we look at that and we say, well, there are numbers. That's numerical. So is it always true that numbers are numerical? What about when you have numbers that are really being used as a name for something? An example from my childhood is airplanes that were famous. There was the 747 and then there was the 737. These are numbers. 747 and 737 are numbers. But they're really names. They're names for types of aircraft. And when you stop and think about that, the thing that makes it obvious that the numbers are actually being used as names is the fact that it wouldn't make sense to treat them the way you normally treat numbers. Like, for instance, if we wanted to know the average of 747 and 737. Well, the average of 747 and 737 I can do in my head. It's going to be 742. I'm adding 747, 737 together, getting the total, and then dividing by how many numbers I had. That's what we do when we find an average. The average of those two numbers is 742, but is there any meaning to that? What does it matter? This number 742, it doesn't really have any meaning, and the reason it doesn't have a meaning is because those numbers weren't really being used as numbers. There were numbers that were being used as names. They're names of aircraft. So now I have another example. Okay, so in the school where I work, I'm not in the school right now, I'm in my basement. The school where I work, we have a room number, and it's room 203. And it's where there's a math teacher named Doug who teaches. That's my classroom, room 203. Next door, there's another math teacher who teaches in room 204. So you won't be too surprised that if my room is 203, then the room next door is 204. The third math class down the hall, though, is in room 207. And there's a math teacher who teaches in there. Are these really numbers, though? 203, 204, 207. They're numbers that are being used as names. We're naming the classrooms. And numbers are commonly used to name rooms in a building where you have a lot of rooms. So like in a hotel, for instance, you have the room numbers. But are they numbers? Well, I asked that question. Would it make sense to find the average? Let's say we're asking our students, okay, which classroom would you like to learn math in next year? Let's find the answer by finding the average of these 3 room numbers, the average of 203, 204, and 207. Okay, well, if we add these 3 numbers together, we get 614. If we divide it by how many numbers there were, which is 3, 614 divided by 3 gives us an average of 204.7. So that means the students should learn math next year in room 204.7. Doesn't make sense. There is no room 204.7. Finding the average of those 3 room numbers didn't make sense because although they are numbers, they are being used as names. So those classrooms, 203, 204, and 207, are an example of categorical data. It's not numerical data. How am I doing for time? We're doing pretty good. These are just some of the basic concepts that we have to think about in statistics so that we recognize the type of data we have and we can make the right decisions about how we're going to treat that data to try to answer questions with it. Now, my next topic is now we get into the measures of center. That's the meat of today's lesson, the measures of center. We're looking at two main measures of center, which are the mean and the median. So I'm going to get into that. I'm going to erase some of this. I'll erase all of these names. I'm leaving the heading statistics up, hopefully for the duration of our statistics unit, but we'll see if I can remember to do that. Okay, the mean. What is the mean? The funny thing about mean is when students have never heard of it before, when they're being introduced to the idea at first, they have this oh yeah moment. The mean is what you get when you take a bunch of numbers and you add them together. You get a total. But then you divide the total by how many numbers you had. Well, we were just doing that, weren't we, when we were dealing with rooms 203, 204, 207 in a way that didn't make sense because they're not really those numbers are not being really used as numbers. But what if you have numbers that really are being used as numbers? So if I ask you to add several numbers together and then divide by how many numbers there were, a lot of the students would be saying, well, you mean find the average? And I'd say, well, yes, because that's what mean is. Mean is the average. Mean is a term used in statistics that means the average. So we'll get used to that. Let's find an average. Let's find a measure of center. Well, what do you mean by measure of center? When you have a bunch of data and you want to try to find a central point so that you can summarize it. That's the idea of the mean, the average. So I'm going to reach into my geometry toys that I was using so much during the probabilities unit, and we're going to find the average of several numbers. So I'll start with these orange squares. Let's just show them quickly. There are 3 of them. So I will put up here, make sure I'm going to try and use my room quite well. So for the squares, we have 3. Okay, what other quadrilaterals do I have? So I'm deciding I'm only using the quadrilaterals, I'm avoiding the hexagons and the triangles. I have these red ones. These red ones are trapezoids, and it's hard to see in the camera, but I have 4 of them. Trapezoids, we have 4. Okay, what other quadrilaterals do I have? I have rhombuses, but I have 2 different types of rhombuses. I have these blue rhombuses, and it's hard for me to show them to the camera effectively, so you'll just have to take my word for it that I have 5 of them. So I'll write blue R for blue rhombuses, and we have 5, and then the other rhombuses that I have are white, so I'll get that down right away. White rhombuses. And how many do I have? I'll show them briefly. And it's hard for you to count in the camera, but there are 8 of these. Okay, so we have 8. We're going to find the mean. We're going to find the average of these 4 numbers. Now, if all I held up was the orange squares, and I said, well, I have 3 orange squares, what's the average, what's the mean? It would have been pointless, right? Because that's the difference between statistical and non-statistical. There's only one answer to the question. There are 3 squares. But as soon as we start having more than one shape with different values, okay, now it becomes statistical and we can ask this question. What is the mean? What is the measure of center, the mean of this data? We're going to get that answer by adding together the 4 numbers we have and dividing by how many numbers we have. So we have 3 plus 4 plus 5 plus 8, and we're going to divide that total by 4, which is how many different shapes we had. 3 plus 4 plus 5 plus 8 is 7, 12, it's 20. And therefore the average, the mean, is 5. The mean of the numbers of the different colored trapezoids that I have is 5. So how could I balance this out? How could I make them all have the same, make each of these 4 collections of shapes have the same amount? Well, I would have to take some of the white rhombuses and share them out between the other. The blue rhombuses, we already have 5. So it's already equal to the mean. If we took one of the white rhombuses and made it an honorary trapezoid, we'd have 4 plus 1, we'd have 5 trapezoids. If we took 2 other of the white rhombuses and put them with the squares, we would have 5 in that group. 5, 5, 5, 5. Well, this is what we're doing when we find the mean. The mean can also be described, therefore, as a fair share. So let's say I'm taking all of these plastic shapes and I'm giving them to 4 students. And I want them all to have their fair share. Well, if I give one of the students the 5 blue rhombuses, that student has their fair share. If I give one of the students the 3 squares, that student's going to say, hey, I only have 3. Not fair. But if I give that student 2 of the white rhombuses, okay, now that student has the 3 plus the 2 has 5. That student has their fair share. Of the 6 remaining white rhombuses, when I take one away and give it to the student who has the 4 trapezoid, everyone has 5. Everyone has their fair share. So this is something that we can do with some numerical data where we can arrange we can calculate what would be the fair share. The fair share would be the mean, it would be 5. It makes sense. Okay, I'm liking this example. Let me look at a second example. I'm going to have to write some values down. I'm going to end up doing a lot of erasing with this unit. Yeah, I think I'll erase the whole thing. Even if I want to use this data again later, I'll just have to summarize it again. Okay, what's my next example? I have some examples here. There we go. So, I have a list of shoe sizes of 8 students. So I'm going to list all of them. Now I'm not trying to list them in order from smallest to largest. That comes in handy sometimes in statistics, but we don't have to do it right now when we're finding the mean. So if the shoe sizes are 13, 12, 9.5, 10.5, another 12, an 11, another 12, and an 8. Okay, so someone has small feet, someone has fairly large feet, and we have a bunch of people who are in between. So we want to know the mean. We want to know the average of these 8 shoe sizes. We have to add them together and divide by how many there were. Well, how many were there? There were 8. So we're going to divide by 8. The total, I know that the students will be able to calculate the total very quickly. And I also know that the students have access to these examples. So if you are following along and you want to have the numbers to work with yourselves, you will see that I'm using some of the same examples that can be found on the worksheets. What I am doing though is I'm avoiding the homework examples because I think the students would probably prefer to do the homework examples themselves without having seen the answers already worked out by a teacher in a video. So that's what I'm doing with this. So this is the 8 shoe sizes, and the total of these 8 numbers is 88. Correct me if I'm wrong, I'm not going to double check. And then 88 divided by 8 is 11. So the average shoe size of these 8 students is 11. It is really that simple. Average is a concept that students have learned before. And then they get to statistics, and the idea of statistics as a unit is new. But one of the things statistics does is it uses average, it uses mean quite a lot. And it's kind of easy for the students when they realize, oh wait, so I'm learning this new thing called mean, but it's actually something that I've already been doing for years and just calling it average. That is good news. Okay, let's do another set of data. I'll do one without erasing. I'm going to do, here it is. I'm not going to necessarily list the meaning of these values. I'm just going to come up with my own examples, but I'm going to use some of these numbers. So let's say, I already did number of pets. Let's say if we go into all the swimming pools of all the people who have pools on my street, and we look at the number of toys that are floating around in each of these swimming pools, and we just keep, we record. How many toys are floating around in each swimming pool? Okay, how many swimming pools am I dealing with? There are 12. I'm going to list how many toys are floating around in each of those 12 swimming pools, and I have the numbers 4, 2, 5, 1, 6, another 2, 9, 8, 7, a 0, a 1, and a 2. So one of those pools doesn't have any toys floating around in it. One of those pools has 9 toys floating around in it. It would be hard to jump into that pool without landing on a toy. Okay, so how many do we have? We had 12 altogether. I want to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I have 12 numbers. So we are going to find the mean. We are going to find the total of all those numbers, and we're going to divide by how many numbers we had. And then how many numbers we had, that's the fast part. There were 12 of them, 12 swimming pools. Okay, when we add together all of these numbers of toys that are floating in the swimming pools, the value I'm getting is 50. I'm going to have to get my calculator sometimes for these examples. What is 50 divided by 12? Should I try to show off and do it in my head? 50 divided by 12. 4.17. Is that the answer I got? I didn't get the same answer that's written on this sheet, so I'm going to double check it. 4 plus 2 is 6, plus 5 is 11, plus 1 is 12. Oh, I'm not getting, I think I looked at the wrong values. 4 plus 2 is 6, plus 5 is 11, plus 1 is 12, plus 6 is 18, plus 2 is 20, 29, 37, 44, 45, 47. It's not 50, it's 47. Found a mistake. 2, 2, 2, 1, 2, 2, 2. Okay, I think I'm just going to have to accept the fact that the answer I was expecting isn't the right answer. 50 divided by 12. .17. So the average number, the mean number of toys that are floating around in swimming pools in these 12 pools on my street is 4.17. And that is a measure of center. It is the fair share, if you will. So what is the fair share of pool toys that should be in a pool on this street? Well, it looks like the fair share would be 4.17. Perfectly good example. Okay, so let's do another one. I'm going to stop looking at the answers because I don't want to trick myself. I'm going to erase one of the examples and then do another one in the same spot. So I'll leave this pool toy example here and I'll erase our shoe size example. And I'll check myself on my time. I'm doing pretty good for time. We're still in the first measure of center and we're going to cover another one. But I want to make sure I leave enough time to give enough examples for both. Now I'm understanding what I did wrong. Okay, so I used some data that was presented and I interpreted the data differently and it doesn't matter. Because the swimming pool example still works, we have a mean that makes perfect sense. That's good. I feel confident. Okay, here's a bunch of ages of people. How many are there? 1, 2, 3, 4, 5, 6, 7. There are 10 of them. I'm going to give 10 ages of people. I'm not going to rely on this data too much because the only reason to be worried about what data I use is if I'm trying to avoid things like decimals, but I know the students in this class can handle getting means that involve decimals like this one. That's not a problem. So a number of people who are waiting in line at a restaurant and we find out their average age, their mean age. I'm going to use 10 ages, so I'll write ages and I will list 10 ages. I'm sort of making up numbers at random. Let's say we have a 22-year-old, we have a 40-year-old, We have the 50-year-old. Let's say we have some 18-year-old twins, and that's 5 of them. I'll give 5 more. I'm pretty sure I can fit all of them in a row here. So we'll put a 24-year-old and a 32-year-old. The 32-year-old has 2 children with them. I'm up to 9. 1, 2, 3, 4, 5, 6. That's 9. And we'll put a nice old person, even older than me, as the last one, a 66-year-old. There. Randomly presented ages of 10 people waiting in line at a restaurant. Let's find the mean. The mean is going to be the total of all those ages, which I'm going to have to carefully add up, divided by how many there were. That's the easy part. There are 10 ages that we are dividing by. And now I will get the total, and I'm going to use my calculator if I can find it. Try not to make a mistake adding these up. If I make a mistake, students are very welcome to point it out. Okay, so the ages: 22 plus 40 plus 50 plus 2 18s plus that 24-year-old, then that 32-year-old parent with the 4-year-old and 7-year-old children, and then that even older than the math teacher 66-year-old, and the total is 281. Now the fun thing about dividing by 10, of course, is that it's an easy one to do in your head. So the average age of these 10 people waiting in line at a restaurant is 28.1 years. Do we measure years with decimals very often, and years and months? 28.1 is going to be 28 years and either 1 month or 2 month old if you want. Okay, so we were able to find the mean. The mean it's a pretty quick little mathematical operation, and it is fun, and students find it easy because they realize they already knew how to do it before they learned what the word mean means. Let's see where I'm doing with time. I'm doing pretty good with time. I'm getting to the halfway point of my time. I think I'll do one more mean. And let me think here, what can I do that's fun? I don't want to improvise too much, because when I improvise too much, I end up getting flustered. But, let's see. Cards. Okay, I'm going to do cards. And it's not a probability question. We're just going to find the average value I get when I pull out, say, let's see how many should. Well, one of the things about mean, one of the things about statistics is to talk about the sample size. How many data points do we have? Well, here we had 10, here we had 12. The thing about learning these tricks with statistics is the tricks still work when you have much larger sample sizes than this. So for instance, if you were trying to find the average grade of all of the students who had to take a first-year course in a university, you might actually have hundreds of students. You might be dividing by a number that's in the hundreds, but the tricks still work. So it's good to work with small amounts of data to start with, to make sure that you understand what you're doing, and then you're not afraid to deal with larger amounts of data. I'm going to erase both of these examples. Now the trick, of course, with trying to talk about numbers using a deck of cards is that not all of the cards have numbers. But one of the things that we do very often with card games is we just decide that we can make a rule that a face card, the king, the queen, the jack, is worth 10. So we'll say the ace is worth 1. All of the number cards are worth their number. That's pretty obvious. And any face card is worth 10. This is not a probability question, but all sorts of fun probability questions pop into my head. I'm going to try to avoid getting off topic with them. I'm going to put, I don't want to use too huge a number in my sample size, so I'm going to just do 14. I'm going to pull 14 cards. The first 14 cards I see, I'm going to put the number value on the chalkboard. So we have, I'll just look at the first 14 cards that happened in the deck when I shuffle. So we have a 9. We have a 2. Wouldn't it be funny if we pulled 14 cards and none of them was a face card? We have a 4. We have an 8. Okay, this isn't taking too long. 7. Uh-oh, got that joker. Jokers don't count. I'm going to ignore it. We have a 5. We have a 6. And I know these cards were well shuffled. Oh, another 6. 2 6s in a row. What are the chances of... Oh, sorry, that's probability. We have a king. That's worth 10. How many do I have so far? 3, 6, 9. Only 5 more. We have an 8. We have a queen. That's another 10. We have a 10, which is going to be worth 10. And we have a jack. Have I got, which is also worth 10. Have I got to 14? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Only one more. And it's a 3. Okay. So it's that easy to come up with a bunch of data. And now we can calculate the mean. The mean is going to be the total of all those numbers divided by how many there were. And the how many there were is 14. 9 plus 2 is 11, plus 4 is 15, plus 8 is 23, plus 7 is 30, plus 5 is 35, plus 6 is 41, plus 6 is 47, plus 10 is 57, plus 8 is 65, plus 10 is 75, plus 10 is 85, plus 10 is 95, plus 3 is 98. 98 divided by 14 is going to be our mean, and it is going to be our answer. And we're in the calculator. 98 divided by 14. 7. Oh, I didn't get a decimal in my answer. Huh. So the mean number that I get when I randomly pull 14 cards from a deck of cards, if I count face cards as worth 10, is 7. Interesting. Okay, so that is a measure of center called the mean, but it's not the only measure of center. And it's time, let me look at my time. Yes, I've gone past the half-hour part, half-hour point of my lesson. It's time to get into some examples of another measure of center, which is the median. Now, I'm going to erase the mean, but I'm going to leave the data that we used for the cards right there because I will be able to use it again. The median is another measure of center. It's also very useful. Mean is very useful. It gives us the fair share. What does median do? Median is the middle value. Now that's kind of interesting. The middle value, well, middle value can be seen as a measure of center when you think about what center means. Here's a bunch of data. We're trying to find the center. We learn this cute trick called mean where we're able to say that the mean of this data is 7, and that sounds sort of central when you realize that the higher numbers are 10s, and the lowest numbers we have a 2, we have a 3. If we had pulled an ace, we could have had a 1. Okay, so yeah, 7 does seem kind of central when you look at this data. But the middle value can also be a measure of center. There are 14 of them. The middle value, in this case, there would be 2 middle values, but we have a problem. When you want to find the median, which is the middle value, you need to rearrange your values, your data points, from smallest to largest. Now, yes, it would work also to rearrange them from largest to smallest. But it doesn't really make sense to say, I can find the middle value of this data the way it is, because they're given in a random order. If I want to reorder these from smallest to largest, this too ends up being first. You know what I'll do is I'll put it down here, because I don't want the numbers clustered too close together. It'll be too hard to read them. So the lowest value we have is a 2. Now this is something that you get used to doing with statistics, is reordering numbers and being careful, because there are 14 of them. It would be really easy to lose one of the numbers by accident, or to count a number twice that we only should have counted once. Part of learning statistics is that you get used to being careful about things like this. Well, how am I going to be careful? I know there's 14 of them. So I'll start listing them all, and then when I think I'm finished, I'll count. And I'll make sure I ended up with 14. And I'll double check and triple check and try to avoid any mistakes, or catch my mistakes and fix them. The second lowest number that I found was this 3. There was only one 2, and there was only one 3. There was only one 4. There was only one 5. Well, here's another trick that we can do. This is a very useful trick when you're doing this step in statistics, is we can cross out the numbers that we already relisted in our new list. So the 2, 3, 4, 5, yes, I can see that I haven't made a mistake. There are 2 6s. There's 1 7. There are 2 8s. It would have been really easy to only count one of the 8s and not notice the other one because they weren't close. They weren't close together. Whereas the 2 6s, it was really easy not to make that mistake because they just happened to be close together in our original list. Okay, after the 8s, we have a 9, just one of them. Is it only one? Yes, I've used all of these numbers that are crossed out over here. All that's left are these 10s, and there are 4 of them. And I will cross them out just because I wanted to do that. I want to finish it. And I'll also count to make sure that I have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now the median is the middle value, but we have an even number. And when you have an even number, there are 2 middle values. So how are we going to find those? When it's a small group of numbers, it's pretty easy to find the middle value. I can sort of aim at it and say, I think it's these 2. I'm not going to draw my circle around them really big in case I'm wrong. 1, 2, 3, there are 6 numbers to the left of that 7. 1, 2, 3, 4, 5, 6. There are 6 numbers to the right of that 8. I do have it right. The middle value, there are 2 middle values, and they are 7 and 8. And the median will be the average of those 2. The average of 7 and 8 is 7.5. That chalk needs to be extended. This chalk is nearly finished. Okay, let me look at my notes for median. There's my median. Okay, so to find the median, we order the data from least to greatest. I did that. And then we find the middle number if there is one middle number. If there are 2 middle numbers, which is always going to happen when you had an even number of data points. There will be 2 middle numbers. You find the average. Isn't that funny? We find the average, which is the mean, of those 2 numbers. And there we are using mean again already. Okay, so the measure of center, the idea of measure of center, when we first saw these numbers, we found their mean, and the mean happened to be 7. I remember that. And then we find the median, which is 7.5. Interesting how both of these values that we got, this is a little bit messy, both of these values do seem to land nicely close to the center of the collection of values that we had. So both median and mean are useful ways of finding the center of a list of a collection of data points. Now, of course, I started with the complicated example where we had an even number, so I have to show a less complicated example. So I'm going to show an example where we have an odd number of data points. And I'm going to have to erase to make a bit of room to do that. How am I doing for time? 38 minutes, pretty good. Okay. Keeping the title statistics, I'll get rid of everything else and I'll put up a new example. And like before, I'm going to take some numbers from one of the examples that's given, but I'm just going to make up my own meaning for those numbers. Let's say, I see 1, 2, 3, 4, 5, 6. I'm trying to find one that has an odd number of values in it. So I see an odd number of values here, and I'm going to say, now what could it mean? There are 9 values, and what I'm going to say is how many, in 9 days in a row, I recorded how many times Mocha ran into the screen door because she didn't realize that there was a screen there and she bashed into it. Because this is something she does quite often, but not all the time. So let's say the number of times in 9 straight days that Mocha ran into a screen door was 2, 0, 2, 1, 1. Oh, another 0, she had a good day. Then 3, uh-oh, that was a bad day. and then 1, and then 1. I knew Mocha would come in handy somehow in this lesson. She's right over there, and she is, we will all congratulate her on what a good job she's doing of not bumping into the tripod and shaking the camera. Okay, so 2 screen door collisions, 0, 2, 1, 1, 0, 3, 1. There happen to be 9 values. But I don't want to find the median. I can find the mean as well if I want. But I'm going to find the median of these. The median, of course, I can't find unless I put the numbers in order. So the lowest number is 0, and I have 2 of those. I have to do this crossing out thing again. That's very helpful. Then we have 4 ones. Easy to draw ones. Okay, cross those out and make sure I didn't make a mistake. 2 2s and a 3. Cross out the 3, cross out both 2s. Okay, do I have 9? 1, 2, 3, 4, 5, 6, 7, 8, 9? Yes. And the middle value is very easy to find because there were 9. So when you have a small number like 9, you're able to say in your head so quickly, okay, well the middle value has to be the 5th one. There would be 4 values to the left of it and 4 values to the right of it. So the median number of times that Mocha bashed into a screen door over the last 9 days is 1. Should we find the mean? I think we will. I think we're going to start mingling our means and medians because realizing that students are probably thinking, okay, median isn't really any more difficult than mean. Mean was easy because I already knew how to do it and I just learned a new name for it. And now median, well, finding the middle value, not so crazy. I have to do a couple more examples with odd numbers. I want to take a look ahead at some of the questions for median. Just for a second. Okay. But I will find the mean of this data. The mean, I'll write it here. I'll put mean, and then I'll label this as median. Median is 1. Just circling it isn't quite enough. I want to actually write the answer somewhere. The mean. The mean is going to be the total of all the numbers divided by how many there were. We know how many there were was 9. The total of all these numbers, 2 plus 0 plus 2 is 4, plus 1 is 5, plus 1 is 6, plus 0, plus 3 is 9, plus 1 is 10, plus 1 is, it's 11. 11 divided by 9, it's going to be 1.22. Am I successfully being a show-off and doing that in my head? This is being a show-off as a teacher who remembers a lot of things from the decimal unit. 11, oh, turn on the calculator, Doug. 11 divided by 9, yeah, 1.22. It's 1.222, it's 1.2 repeating. We can write it as 1.2, we can round it as 1.22, we can round it as 1.2, we can write it as 1.2 with this line over the 2 saying that the 2 is repeating. There's different ways of writing the answer, but now think about the idea of the measure of center. How good is the mean as a measure of center? It's 1.22. Well, our lowest number was 0, and our highest number was 3. 1.22 is kind of central. And then how about the median? Our lowest number is 0. Our highest number is 3. 1 is, yeah, I guess it's kind of central. They're not really smack in the middle central. They're not doing as good a job as our previous numbers were of landing in the center. But that's okay. The difference in the examples is simply the difference in the data points that we had. So when you learn how to find mean and median, sometimes you're given a beautiful set of data where the mean and the median land in the center really nicely, and other times you're given a clumsier set of data where they don't land quite as close to the center, but they are still considered to be measures of center. And you have still found correct answers. Okay. Let's look at another example. Now this one had an odd number of data points, so there was only 1 value in the center. Let's do another one. I'll just erase and do another one. And should I try and be creative and come up with my own example, or should I look at the numbers over there? I'm going to look at the numbers over there, but I'm not going to try to do the same example. I'm just going to use their numbers. And the reason I decided to do that is looking quickly at these values, I'm using values in a question to answer a different question than that question is asking on the sheet. And that's something that happens with statistics, is that you can just take a set of data and use it to practice the thing that you're doing, and you don't necessarily have to use it in the way that it was presented to you in that question. So I have a bunch of values. I'm going to look at all of these examples. Yeah, I'm going to use one of the examples from mean, but I'm going to find the median of the data. So we have 27. How many are there in this case? 3, 6, there are 10 of them. So there are going to be two middle values because we have an even number. 27, 52, 60. Why I'm doing this, I will explain. 41, 33, 38, 42. I'm really getting low on this chalk. This is about the last example for this piece of chalk. I got to 42, 57, 72, 68. Now, why did I feel like using these numbers? Because they're bigger. Because the trick with median, finding median, certainly it works with numbers like Mocha smashing into screen door type of numbers, 0, 1s, 2s, 3s, but it also works with larger numbers. So I just decided I would wanted to show that. But we have to reorder these numbers from smallest to largest before we can find the median. So I have to be careful. It's a little bit easier to get lost in all the numbers when you look at these because we have two-digit numbers. They're bigger numbers than we were working with before. Where's my lowest one? I think the 27 is the lowest one. Cross it out. Then we have in the 30s, 33 and 38. Cross those out. 40s, we have 41 and 42. Cross them out. In the 50s, we have a 52 and a 57. Okay, it's time to give up on this piece of chalk. We'll dispose of it, and I'll grab this other chalk holder, which hopefully has a longer piece of chalk in it. Yep, pretty good. Might even last me to the end of the hour. How am I doing? 13 more minutes. Okay, after 57 was 72 and 68. 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8. No, that's 9 numbers. Wait, slow down, Doug. 27. It's because I'm putting them in order, and I forgot I was doing that when I got distracted by my chalk. Okay, so we had gotten 52 and 57. I have to cross those out. The next number is 60. That's the one that I was forgetting to put. Cross it out. Then 68 and 72. Cross them out. 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's working. I don't think I made a mistake. We are going to find the middle number, but there are two middle numbers. When you have 10 numbers, which ones are going to be the middle ones? The 5th and the 6th. When it's a small group of numbers, it's easy to do that. 1, 2, 3, 4, 5, there. The 5th and the 6th are the 42 and the 52. And the average of those, I'll write median. The average is going to be 42 plus 52 divided by 2. So we have the median exercise that makes us practice our mean exercise. And 42 plus 52 divided by 2 is going to be 47, isn't it? 42 plus 52 is 94. 94 divided by 2 is 47. Yes. So what am I doing? I'm realizing that, yes, I can add these two numbers together and get a number that I can divide by 2 in my head. But I'm also realizing 42 and 52 are 10 apart. So the value that would be halfway between 42 and 52 is going to be 5 more than 42 and 5 less than 52. Yeah, 47. So there's more than one way of answering the question. So the median is 47. Should we find the mean? I'm not going to write it all out, but I'll say mean. And I will find the mean, why not? I will be using my calculator for this, if I can find it. Okay. Now I can use the reordered set of numbers or the original set. It doesn't matter when you're doing mean. The median, they have to be ordered from smallest to largest. With mean, they don't. So I'm going to prove that by using these. 27 plus 52 plus 60 plus 41 plus 33 plus 38 plus 42 plus 57 plus 72 plus 68 equals 490. Divided by how many there were, which was 10, so the average is 49. So using these values, and I know that if I look at my examples, I'll see, because this set of numbers was actually given in a question where the student was being asked to find the mean. So I'm going to see that the mean was 49 when I look at the answer, but I'm so confident that I'm not going to look at the answer right now. What I am going to do is I'm going to do this again. Clear? But this time I'm going to use the reordered set of numbers because I really want to get the same answer. Okay, 27 plus 33 plus 38 plus 41 plus 42 plus 52 plus 57 plus 60 plus 68, I'm going slower as I keep going, plus 72, I'm getting nervous, equals 490, I don't have to divide by 10 again. 490 divided by 10 is going to be the same answer as 490 divided by 10, isn't it? So I am feeling quite confident. I have found both the mean and the median of this set of data without even knowing what the data was supposed to represent, because I never bothered to read that part. And I have therefore found both of the measures of center that we are working on learning about finding. Let's see what I have in my notes. That's page 1, there's page 2. I think what I want to do with the few minutes I have left, I want to try just once to do a larger sample size. We have a lot of 8s and 6s and 10s, and I even did a 14, and there may be some 12s in there, 11s, 9s. Well, come on, Doug. You're saying that if you have much larger data sets, you can still do these tricks. Prove it. And if you make a mistake, you know, sometimes it's good to make mistakes. If you make a mistake, the students will notice, and they will make a comment, and they will correct my mistake. That would be funny, of course. All right, I want a larger data set. I don't have time to do a crazy large data set like 300 or anything like that. I want to be able to show the data. And just writing down 300 numbers would take more time than I have left in this planned 1 hour long video. Okay, so I don't know if I want to bother. I'm not going to bother coming up with a meaning for these numbers. I'm just going to put up a bunch of numbers, and it's going to be more than 8 or 10 or 12 or 14. So how about, and I'll use an odd number so that finding the median, finding the middle value is a little more straightforward. We don't have 2 middle values if we have an odd number. So let's see. Should I do it with cards again? I think I'm going to do it with the cards again, which would be easy if I could find the cards. Here they are. I better shuffle. I don't want the list of cards that I find to sound too repetitive compared to the previous example. But how many should I put? Less than 52. Okay. 4. It's tempting to just throw the cards on the floor, but I'm going to end up slipping on one and falling. So I'll put it in the back. 5, 9. And I also want to make sure that I can fit them all in one line. So I can't put too large an amount. I'm going to put some other numbers over here. After 9 we have an ace, which is a 1. A king, that's a 10. A 9. A 10, an actual 10. Oh, another actual 10. Better put a comma there. Now I'll go up past the 9 and I'll put some more. 7, 5, king, that's a 10. 10, that's a 10. 3, how many do I have so far? 3, 6, 9, 12. The 3 is the 13th. 6, 2, king, 4, 8, 8, queen, that's a 10. 7, now how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah, 13, 14, 15, 16, 17, 18, 19, 20, 21. After the 7 is a jack, that's the 22nd. The queen is the 23rd, it's worth 10. Another queen is 24th, that's worth 10, and I'll put a 3 because I have a feeling nothing more will fit. Where am I? Can I see my finger on the, yes, wow. Okay, so the 3 fit. I could put a few more over here, but I think we have enough to make the point that yes, we can find the mean and the median, we can find the centers of a larger group of data. It just takes a little bit longer. And that thing about crossing out the numbers when you reorder them is going to become more and more important when you have larger sets of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25. My sample size is 25. One day in statistics, we will learn that N stands for sample size. Okay, so I'm writing that down so that I don't forget it. Now, to find the median, I have to reorder these numbers from smallest to largest. Oh boy, what have I got myself into? I'm going to write a little bit closer together so that I don't have to walk so far. So I'll start out a little closer to the center. Closer to the center, isn't that funny? 1, cross it out. Any other ones? I never got another ace. How many 2s did I get? There's the only 2. How many 3s did I get? There's 1, and there's 1 right at the end. So I'll cross out both 3s and the 2. How many 4s did I get? There's a 4, and there's a 4, 2 4s. Cross them out. How many 5s did I get? 1, 2, just 2. This isn't so bad. How many 6 did I get? Those are 9s and 10s. There's a 7, 10s. Here's a 6. Only 1 6. There's that 7 I mentioned. I need to take a drink of my fizzy water. There's a 7. I'll cross it out. But there's another 7 over here, so I'll cross that out and I'll put it. Now, how many 8s? No 8s over here. 2 8s in a row. What is the probability they would have landed right in a row? Stop it, Doug. It's not probability anymore. 8, 8. You know, if there was a relationship somehow between probability and statistics, then it would make sense the way that I think probability pops into my head all the time. Maybe there is a relationship between probability and statistics somewhere. Okay, so 2 8s, I got them both crossed out. How many 9s? I have only 2 9s. Both crossed out, both listed. How many 10s? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10s. Lots of 10s. Why did that happen? Face cards. That's why it happened. What is the probability of... Never mind. Okay. So, to find the middle value, okay, there's 25 values. 25, if I divide it by 2, 25 divided by 2 is 12 and a half. So it means the middle value has to be somewhere around 12 and a half, 12, 13. And then I think about it and I think, yeah, I could think of a group of 25 things, well, you know, like this. And I'd say, well, if I look at 12 of them on one side, 12 on the other side, I've shown 24 of them. So that means there should only be 1 left in the middle. It's going to be the 13th value. If I count 12 values, I'll do a little box. 3, 6, 9, 12. There's 12. I'm showing 12 values over here. And if I show 12 values from the other end, I really shouldn't start here. It's kind of presumptuous. I'd rather start at the other end. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10, 10, 11, 12. There's 12 values. Okay. So I kind of did the opposite of what I normally do when I circle the middle value. I put big rectangles around all of the other values, and I can see that my middle value, my median, is 8. How central does that seem? When you know that the values go from 1, there's no zeros in this, right? There is no 0 card. When you see the values go from 1 to 10, you'd think central would be around 5. 86. 8? Why did that happen? Oh yeah, it was all those face cards again. I don't know, I'm starting to really like using cards for statistics. You would have thought they'd only be useful for probability. So the median is 8. The average, the mean, do I have time? Yes, if I go really fast, I'll have time. So, I'm going to have to do some of my show-off math to go fast. I'll use these reordered numbers because that'll help me to go fast. There are 10 tens, and 10 times 10 is 100. So the total of all the tens is 100. Then 2 nines, that's 18. I'm writing messy. There. 2 eights, that's 16. 2 sevens, that's 14. Am I going down off the camera? No. Only 1 6, but with 2 fives, I'll take the 2 fives and the 6 and I'll say that together is 16. 5 and 6 is total of 16. I'm being cute here. 4, 8, 11, 14, 16, 17. Total of all the others is 17. Now to go fast, 100 plus 18 plus 16 plus 14 plus another 16 plus this 17. The total for my mean is 181. And I have to divide that by 25. Divided by 25, 7.24. So even with a larger set of data, if we're careful, we can find the measures of center. We can find the median, which is 8 with this data. We can find the mean, which is 7.24. And we can think about how central do those seem. Both of them seemed a little bigger than I expected, but then I can also see the reason why. Because of this big cluster of tens, and that happened because of the type of experiment I chose to do. When I decided that face cards were worth 10. I could have decided that jacks were worth 11 and queens are worth 12 and kings are worth 13, and then my answers would have been a little different. My median and my mean would both have been even higher. I think. Anyway, we have gotten to the end of my first lesson in statistics. I want to get my beautiful assistant over here so she can say goodbye. Come here. Come on. Took the 2 sets of whistles for her to realize that she was being paged. Now she's doing the cute little stretchy thing. Okay, so I've gone slightly over my hour. I'm pretty happy with this lesson though. We want to remember that we need to know whether data is categorical or numerical. Notice that all of these mean and median examples I've been doing have involved numerical data. And we want to think about whether a question is statistical or non-statistical. When I ask how many dogs are standing right near me, there's only one answer. The answer doesn't vary, so therefore it's non-statistical. But if I ask, okay, how many dogs are owned by each of the people who are watching this video, or at least the people who watch this video, the first 100 views the video gets, then okay, that has become statistical because the answers are going to vary. So we've covered the categorical numerical, we've covered the statistical, non-statistical. We've had a lot of repetition for mean and what it really means, which is average, and the fact that we kind of already knew it. And we've had a lot of repetition with median, and how median is still kind of easy, but you have to watch out. There are, sometimes there is 1 middle value and sometimes there are 2. When there are 2, you have to find the average of the 2 middle values, which means finding the mean of the 2 middle values. And we've talked about how quick it can be to find median when you have a small sample size, and how it can become a little bit more trouble, but is still doable when you have a larger sample size. I think that recaps very nicely what we did in this lesson. Come here. You haven't actually waved goodbye yet. Ugh. From me and from Mocha, enjoy thinking about statistics in your dreams, and I look forward to our next lesson.